motivation for building TonY, as well as some quick overview with TensorFlow and Hadoop. And by the way, how many of you guys use TensorFlow? So like half of you. And how many of you have used Hadoop? Roughly the same amount. How many of you guys have used PyTorch? Curious. I'm always curious about that. There's, PyTorch and TensorFlow are probably the two most popular frameworks out there. So after that, Jonathan will talk about TonY's architecture and features, and then Kush is going to show you how to use TonY, give you a demo. Of course, we're working on LinkedIn, so you got to promote our vision, which is to create economic opportunity for every member of the global workforce. And so, we're creating an economic graph, which includes our 575 million members. We're trying to have all the companies on there and have all the jobs you can apply for, as well as the skills you need, the schools you might go to, et cetera. Part of the LinkedIn experience is, recommending to our members what jobs they might be interested in applying for, or what skills they may like to learn. And so there's a lot of machine learning behind this to, develop personalized recommendations for our members. And so we use a lot of machine learning models to do this. Most of our, recommendations are done using fairly traditional machine learning. Things like decision trees, linear models, things like that. But as is commonly found, those things have a quick ceiling where as you increase the data, the accuracy of your model kind of fails to keep improving. But with neural networks, a lot of times, especially with deeper networks, as you scale up your data, your model accuracy and performance can continue improving. So to improve our recommendations, we're kind of experimenting with these deep learning models. But of course, the challenge with this is you have to scale the infrastructure to support it. And as our previous speaker mentioned, one of the challenges with advanced AI is you have to keep scaling infra and make sure that's not the bottleneck. We could have supported any machine learning framework, but if you take a look at which frameworks are used in recent machine learning papers, you'll notice in the past few years, TensorFlow has really skyrocketed in popularity. If you take a look at the GitHub activity of these projects like TensorFlow and Cafe and Keras, et cetera, TensorFlow has by far the most activity. Part of it might just be because Google is a huge organization behind it, but right now it's definitely one of the most popular. So we decided to invest our resources first to support TensorFlow, but the way we've architected TonY, it can also support other frameworks. In fact, we do support PyTorch now. So just a quick overview of TensorFlow. It came out of Google. It's a machine learning framework, general purpose. You can do deep learning on it, but you can also do decision trees and regression models, such as the example here. And the general idea is you're creating a graph of operations on tensors, which are just arrays of numbers here. And once you've constructed your graph, you train your model on some data. So inside a TensorFlow section, you feed in your data here, and you iterate over some number of epochs here. TensorFlow also has a lot of visualization tools. When you're developing your model, you want to see what it looks like, what's going on, drill down on your model, and you also want to see how your training is progressing. TensorBoard also lets you visualize your training progress live while it's going on. Quick overview of Hadoop. You might be wondering why we run TensorFlow on Hadoop as opposed to Kubernetes or Mesos or some other system. Well, that's mainly because at LinkedIn, we're a Hadoop shop. We store most of our data in Hadoop. We don't run Kubernetes or Mesos. And Hadoop has two main components. One is the storage layer, which most people are probably more familiar with. That's HDFS, and that stands for the Hadoop Distributed File System. But I want to focus more on the compute layer, which is called Yarn, stands for yet another resource negotiator. And Yarn is what you interact with when you're scheduling jobs on Hadoop. So when you're running a MapReduce job or Spark job, you're talking to Yarn to schedule your containers and run your job. So this is what we're working with for TonY to run TensorFlow jobs. So the way it works is, as a client, you submit an application to Yarn, and Yarn will give you a container back. And in the container, you can start your application master. Your application master can then ask for more containers, for example, to run 100 map tasks. And so you can request a containers, and then Yarn will give you back the containers, like so. And then once you've got these containers, the application master can then start the map tasks or the Spark executors, or in our case, run the TensorFlow job in here. So application master can talk to that. All right, so when you're first developing a model and playing with TensorFlow, you're usually doing this on your personal laptop, right? But then as you want to scale up your data and train on your full data set, you want to use more machines, more parallelism, you can converge faster and get results faster. So let's talk about distributed TensorFlow. So with distributed TensorFlow, there's generally two types of tasks. You have worker tasks, which do the training, and then you have a parameter server task, which store the parameters in your model. So as was mentioned before, generally each worker has a full copy of your model, and they're training on a different partition of your data. And then they'll train on that partition and send their parameter updates to the parameter server. The parameter server will average all of the updates and send the updated values back to the worker. So in order for this to work, all of the tasks need to know about each other. And the way you do that is they all have to know about the whole cluster. And that's defined in a cluster spec, which has all of the hosts and ports for each worker and parameter server. So you send that to all the workers, they can connect and do distributed training. So if you have a bunch of machines lying around, you can do this manually. You can SSH to each machine and run a command. But of course, this is pretty tedious. You gotta do a lot of copying and construct this cluster spec manually. Worker 0 worker. It's pretty tedious to set up, and if anything fails, you got to figure out which job fails, and if you want to find the logs, you got to aggregate them across all the machines. So this is pretty tedious, and we wanted to simplify this experience. Next slide. So we already have a cluster manager, Yarn, which is used to schedule distributed jobs. So we wanted to leverage Yarn for what it's good at, for managing the cluster resources, enforcing user limits to make sure no single user uses the entire cluster, and to make sure multiple users are not fighting for the same GPUs. As you know, a lot of models training can be sped up using GPUs, and Yarn, as of Hadoop 3.1, supports GPUs as a first-class resource. So just like you can request 2 gigs of RAM or 2 CPUs, you can also request I want 1 GPU per worker. So we leverage that feature in Yarn as part of TonY. And so when you're developing locally, if you want to scale it up and run in a distributed fashion, you should be able to do so without changing your code too much. So that's something we strive for too. And while you're running, you want to have TensorFlow running so you can visualize your results. So we took a look at some open source solutions before we started building our own. As I mentioned earlier, a lot of companies use Kubernetes, and for that, there's a project called Kubeflow that's kind of similar in spirit to TonY, this machine learning framework, and it has the GPU support. it supports the ability for requesting GPUs for just your workers, but not your parameter servers. The heterogeneous research support, and you can also launch a TensorBoard in a separate kubelet. But however, it runs on Kubernetes, and frankly, we're not going to switch to Kubernetes anytime soon. We are a Hadoop shop, so that kind of ruled out that option. So then we took a look at some other solutions built on top of Spark and Hadoop. And we actually started out using Yahoo's TensorFlow on Spark. And this allowed us to get up and running. But it didn't support GPUs out of the box. We had to do some hacks to get that to work. However, in the latest Spark and Spark 3, which has not been released yet, they have added GPU support, just FYI. However, with Spark, you request like say 10 executors, but all of them have the same profile. If you request the GPUs, you'll get a GPU on each executor. But really, it's only the workers that are doing the training that need the GPU resources. The parameter servers are pretty lightweight and just average the updates and are fine with just CPUs. So you really want the ability to have different kinds of resources, and that's still not something you can do with Spark. Down here, there's some solutions kind of built directly on Yarn, such as Intel's TensorFlow on Yarn project and Choose XLearning. Intel's project hasn't had any activity for about a year and a half, and again, it lacks a lot of these features that we desired. XLearning, finally, is very similar to TonY, but we didn't discover this project until a few months ago. It was actually built around the same time frame in the first half of this year. And again, it supports many of the features TonY does, but the GPU support is not there. But if they upgrade to the newest version of Hadoop 3.1, that's something that wouldn't be too hard to add in. So after taking a look at these open source solutions, trying out TensorFlow on Spark, we ultimately decided we wanted to build our own solution called TonY. And now I'll turn it over to Jonathan, who will tell you more about that.
Okay, thanks, Anthony. Okay, so what is TonY? So basically, to talk about what TonY is, I think it makes sense to compare it to some other existing computational platforms that you may be familiar with. So Spark, I'm sure many of you know about. So Spark is like a performant computation engine that's also built on top of distributed systems. So at LinkedIn, we also use a lot of Spark. So users will write their Spark scripts, and then they need a way to run it on our Hadoop clusters. So in Spark, there are many different modules that allow you to run your scripts in a distributed setting. There's like a Mesos component, as well as a Spark on Yarn component. So this is the component that orchestrates the translation between your Spark script to the execution. So you can ask the same question about TensorFlow. You have users writing these distributed TensorFlow scripts. How do you run them on a Yarn cluster? So this is where TonY comes in the picture that does the translation between these two layers. So TonY, some of its responsibilities are it orchestrates running your distributed TensorFlow scripts on Hadoop. It'll also acquire the compute resources from Hadoop for you. So in our case, you need memory, CPU, as well as GPU compute resources. TonY will also handle the setup and launching of the distributed TensorFlow jobs on your Hadoop cluster. And then once your TonY job is up and running, then it will manage your application's lifecycle, which includes fault tolerance and job monitoring. So this is the high-level architecture of what TonY looks like. So the parts in dark blue are the TonY components. The purple part at the top is your Hadoop cluster, and then the light blue part at the bottom is the user's provided TensorFlow job. So when you kick off your TonY job, the first component that comes into play is the TonY client. So this is the entry point for all of your TonY jobs. So this component is responsible for packaging the user's configurations, their model code, and then submitting that to the Yarn cluster. So after the application is submitted, Yarn will spawn a container which will launch the TonY application master. So this component is the brains of your TonY application. It'll do job setup and lifecycle management, as well as based on the user's resource requirements, it will negotiate these compute resources from Hadoop. After it gets these resources, it will set up the container environment, and then it'll launch the containers remotely across the allocations previously given. So after these containers are launched across your cluster, each container will spawn what we call a task executor. So you can think of the task executor as a wrapper around the user's TensorFlow job. So the task executor will just launch the user's provided Python script as a sub-process. And since the task executor is just a wrapper around the user's TensorFlow job, it can handle things in the background, such as heartbeating to the application master to make sure the underlying TensorFlow job is still alive, as well as do things like send metrics and other things. So next we want to talk about how TonY helped us scale running TensorFlow, distributed TensorFlow on our Hadoop clusters. So to talk about this, first we want to talk about what running distributed TensorFlow was like before we built out TonY. So initially we had like an unmanaged set of GPU machines. We had like 4 or 5 machines that everyone had access to, each with 4 GPUs on it. And if you wanted to run distributed training, you would have to orchestrate the distributed training yourself. So you would have to construct this command line argument on all of the hosts that are going to participate in the distributed training, as well as you need to copy all of your artifacts, including your code, your configurations, to all of the hosts. You also need to handle the data partitioning yourself. So for us, all of our training data is sitting on HDFS. And so you need to handle the partitioning, copy it to local disk before you start training, which can get very time consuming, the larger data set you want to train on. And also, there is no support for resource multi-tenancy, since all of these machines are unmanaged, and it's basically just a free-for-all for whoever can grab compute resources first. So how does TonY help solve these issues? So first of all, instead of having these unmanaged machines, we put all of our GPU machines into a Hadoop cluster. So now we just have a cluster of Hadoop managed machines instead. So basically, you can go through TonY to find the available resources, compute resources for you, which solves the multi-tenancy issue. You don't need to do that part yourself. Next, you no longer need to copy all of your artifacts to all of the nodes. You only need to copy it once, and then TonY will handle the localization of these artifacts for you. And then TonY will also handle starting up the each worker and parameters. So also TonY allows you to run GPU training in a Hadoop cluster. So in order to get this to work, you need GPU support in all layers of the stack, from your TensorFlow, your TonY layer, and your Hadoop layer. So the TensorFlow layer already has GPU support. And as Anthony mentioned, Hadoop also recently added GPU support. So we just needed to build that into TonY. So basically, this will ensure that when you request GPU resources, the GPU scheduling and isolation is handled for you. So for example, if you have 2 nodes in your cluster, one which has 3 GPUs being used on it, and then you request a third container with 2 GPUs. The Hadoop cluster is smart enough to know not to schedule your process on the first node, and it will find a node that has at least 2 GPUs available to ensure that your job gets your requested resources. So next, we also added TensorBoard support. So before we had TonY, if you wanted to see your TensorBoard UI, usually you launch your TensorBoard process in one of your workers, and then it will read from logs either locally on HDFS to display metrics and things like that to the user. So for us, the problem was that your TensorBoard process is usually listening on some arbitrary port on a random node. And we have some firewalls in place to prevent users from viewing that from their local desktop. So what users would have to do is, after their training's done, they would copy their HDFS checkpoints locally to their local machine, start up a separate TensorBoard process pointing to their local logs, and they can view the metrics that way. So we solved this issue by having native TensorBoard support in Hadoop as well as TonY. So Hadoop has this concept of a tracking URL. So every Hadoop application that you launch has its own dedicated URL. And so we added some infrastructure support in Hadoop as well as to TonY to find the location of your TensorBoard UI wherever it is in all of the workers. Send that to Hadoop, and then you can access it with one click through your application's Hadoop UI. And finally, we addressed the fault tolerance issue in TonY. So the more data you have to train on, the longer your training may run, and the more workers you may need to run on, which makes it more vulnerable to transient failures, such as hardware issues or nodes going down for whatever reason. So usually in a TensorFlow training, one of the workers will be writing checkpoints to HDFS. And then if a worker happens to fail for whatever reason, then TonY will detect that. It will handle the teardown of the rest of the workers, and then do the re-request of resources from Hadoop for you. It'll go through it'll respawn your distributed TensorFlow training, which will read your checkpoints from HDFS, which were saved in the previous job attempt, and resume from where you left off, so there's minimal work loss. So next, I want to turn it over to Kachu, who will talk about how to use TonY.
Okay, so now you understand like what is the problem TonY is trying to solve, and also like how TonY works. So next is the more exciting part, like how you can use TonY, right? Like how everyone can use it. So there are actually a couple ways to use TonY, but before you want to use TonY, you have to build your own models. So TonY is only a framework to run your model, but it cannot help you to build the model. So you still want to start to build your TensorFlow model, or you build your own text torching model. So for example, like some Python script on the right. And then you can start the TonY job from command line. So it's actually pretty easy, and you just need to similar as other like Java program, you need to download the Jar file. For example, as the one like shown on the right, you need to download the TonY CLI like our jar. Then you can just start the command by passing the class. And also, there are only 2 required parameters, and the other one all have default values. So you have to specify, for example, the source directory, which contains the file you want to execute. And the next one is to execute arguments, which basically like which file you want to start training. And we also provide more than 20 configurations to help you like tune your job to make it more easier for you to use. And that is one way, but however, not everyone likes command line, right? Especially for our data scientists. Everyone prefers to use UI. So we have also another solution to run TonY jobs through UI. So this is using like an Azkaban. How many of you know what is Azkaban? Okay, so a couple of hands. What about Apache Woozy? Okay, so basically Azkaban is a tool to visualize the workflow and help you manage workflows. For example, if you have a machine learning job, right, you will do some pre-processing, some feature engineering, and also some model deployment or some cleansing. So Azkaban will help you to like manage the workflows. Like for example, have some dependencies. For example, you will start a training job after the feature cleaning is done. So it's also open source by LinkedIn, and we use this one internally for our workflow management. So if you are using Azkaban, you just need to have a static file which can fix for your job. So for example, you can have like so this is like one-time thing. You just need to configure this once in your in a Azkaban job file. So you can specify like for example, same as before, you can specify the source directory and which file you want to execute. You can also specify, for example, for private servers, how much memory you want to specify, or like how many GPUs for the workers, and also how many instances you want to use for the workers. And also you can specify at the end, like it depends on some like features of formation training before you want to start this training job. So after you have configured your job, you can just upload your job, your zip file into Azkaban UI. Then you can start running your flow in the Azkaban UI. Next, and once it's started, you can start monitoring your applications through logs or through like transport. So next, some like real life demo.
Hold this.
Okay. So this is the Azkaban UI, and for example, the one I'm trying to run is this one. By the end, is the TensorFlow for the inception model, and the data set we are using is the ImageNet. So in order for you to start a job, so this is basically your project, and you can upload, for example, the workflow specification or like the Python dependencies and also the script by using the upload button here. You can see the upload button here. And once, let me make it larger, it's too small. So once you have done that, you can just go to your execution flow, the graph. So this is like the graph you want to run your the training. For example, as I mentioned before, you can specify some feature transformation, or like for example, just want to like catch some libraries. So as I've started already, so let me see if I just can run this job. And run execute. Oh, so it's already, it has been running. If you go to executing, go to my projects. So this is my previous execution. And you can see all the logs here. So here's logs printed out from like TonY. So for example, it will help you like acquire all the tokens, and also so this plugin is also like in TonY repository. Like how can you like integrate TonY with Azkaban? So here you will say like all the logs. Plus you will also say like for example, where's the transport, right? And also where's the in this link, and also like where's the resource manager page. So you can see all the logs. And also there's another way to see the logs. We also like print out all the logs like from in the Azkaban log. So you can see the logs by typing on the links. And that's it for the Azkaban demo. Okay, so yeah, next question is like, so this is something I was thinking about when I was at home. So basically, the problem is like, suppose right now, like I have a new startup, right? Suppose I have, I'm the CEO and I'm trying to like onboard deep learning to my like company, right? Suppose I have like just like some bare metals, or suppose I already have some like virtual machine from AWS or from Azure, right? So is that easy for me to deploy like the combo? Because like right now, if you want to use TonY, you also have to use Hadoop, right? So how hard it is to like run both, to deploy both Hadoop and TonY into your cluster. So actually, I find it's actually pretty easy and straightforward. And also the hardware requirement is also pretty easy. So it only took me like one night to make this work in my like Raspberry cluster. So at my home, I have 10 Raspberry Pis for my like smart home to control, for example, surveillance systems, and also, for example, like out plugs, Wi-Fi controls, etc. So for this case, I try to deploy Hadoop to my like 5 Raspberry Pi cluster. So they are Model 3B+. Even though it's like only like palm size, right? It's very small, but it's actually pretty powerful. It has like 1.4 gigahertz CPU for like 4 cores. It also has like 1 gigabyte memory. And it also has a pretty good like Ethernet card, like 300 megabits per second. So yeah, so this is actually pretty easy. So next we're gonna have another quick demo, like how you can like run this TonY job inside like a Raspberry Pi cluster. Okay, so before we start, we have to connect to my home VPN. And my home VPN is also hosted in the Raspberry Pi. So I'm using the OpenVPN as my client. A second.
Oh.
Okay, now it's connected. Let me make this larger. So let me get to my Pi. Let's get to the other one. What's this one's? Right. Okay, just make sure I'm not like cheating you guys. Let me see. Let's see what's the operating system. As you can see, like I have like 5 Raspberry Pis. They are running the latest Raspberry OS, the latest, I know the best, the Stretch OS. Actually, you have to upgrade to this one, otherwise you cannot use it because in the previous version of like Raspbian, it only supports Python 2.4 or something, which does not support TensorFlow. And also, like for the memory, you can see it has like 1 gigabyte memory, right? So it's pretty small, but actually it's okay for like for the training because you have to turn on the swap space because like if it only has a 1 gigabyte memory, you have to turn on swap space for the actual training. So after you understand after you see the spec for the machines, let's see what you need for the training job. Okay, so this is not needed, and this is not needed either. So this is all you need. So the first thing you need is the source file, right? Basically, where are the models? So for example, the example we took is from the TensorFlow examples. It's basically a very simple distributed MNIST example for the image classification, which is basically the same. And that's one thing. The other things you need are two extra files. The first one is the TonY CLI or the job file, which I mentioned before in how you can use TonY. And the other one is the TonY.xml. So this includes like all the customized configuration for your job. Like for example, here I have like 2 flags. The first one is the TonY application insecure mode. So this means like I'm running inside an insecure cluster because configuring like kernels for like a Hadoop class is pretty hard, right? So for my Raspberry, I don't bother to like make it secure. That's why I only use like insecure mode for my cluster. And the second thing is the JVM like memory, JVM like memory heap allocation. Because like by default, the default XMX will be 20% of your hardware memory, but that's not enough for my job. So that's hard coded like 500 megabytes for the training job. And once you have done this, you just need to run the command as I previously demoed in the slides. So basically specify the class path and then just run the command. And that's it. So the training has started. So right now it's like talking to the resource manager to asking for the containers to run the job, right? As mentioned by Anthony, you have to negotiate with the RM to get the containers back. Let's start your training job. So let's go to the, okay. Yeah, so you can see the training job. Oh, get some problem with DNS. So this is the Hadoop UI, the resource management UI. It's also hosting in my Raspberry Pi. As you can see, the job right now is being accepted by the RM, but it's not, right now it's running. So if you go to the job, you can see it's already running here. And yeah, you can see like they are, because by default, if you don't specify how many primary servers or how many workers, it will be default to 1. So in this job, for example, it will have like 1 application master, which is this one.
And the other one is the primary server, and one will be the worker. So you can also see the log links here in the client. So for example, you can go to the workers log and see what's going on. For example, the standard error. You see the TensorFlow jobs has started. So after like 1 or 2 minutes, it's gonna like start the actual training job. And yeah, and also if you are interested, I can also show like something fancy, like for example, for my smartphone. Oops. Yeah, this is like my home surveillance camera for my home to monitor what's going on. And also what's fancy is like the room over there is the gym, so which has like, so I can monitor in real time whether there are people occupying the room, so I can go when there's no people there. It's pretty useful. You can also build some like fancy like face recognition, right, to detect if there are people like moving around. And also like for example, yesterday was like Halloween, right? So how do you know who's knocking the door? It can be also use this one to detect what's going on. Yeah, that's another talk. Let's go back to the main topic. Okay, so next thing is it's actually open source already. We open sourced this one around 2 months ago. So we talked about this one before as well in the Strata conference. So we open sourced the day before the talk. It was like a long night as well. We spent around quite a couple of hours till around 2 a.m. to make this open source before our talk in New York City. So run is open source on the github.com and /linkedin/TonY. And also we also have engineering blog posts about how to what was our motivation and why we built it. And of course, any contribution are welcome. And either some like typos in the doc or yeah, we actually have a recent contribution from our manager. He just changed like one single space, but it's also some kind of contribution. And also you can also contribute code for sure. Yeah, and it was also because like when we send out like some acknowledgements, right, we also like separate users and also committers. So that's why if you contribute even like one single like space, it's also make you like a committer in our code base. You can also get a t-shirt because if you are committed, so in your company. So yeah, that's why like he made like one single commit to our repo.
So if we remove the space, do we get a t-shirt?
So yeah, so here are the next steps, and we can discuss about that later. Yeah. And so first thing we want to support like other deep learning frameworks. So originally, as mentioned in the very first step, right, it's called TonY, which is TensorFlow Young, because I think we chose like TensorFlow as our deep learning frameworks. But we added PyTorch later. You know why? It was because of like some like real like PyTorch fanboys. So we also gave this talk before, right? And after the talk, the first questions was asked by some like college graduates. They asked, "Oh, we are really into like PyTorch. I mean, PyTorch is the future. Then why don't you support PyTorch?" Then that afternoon we spent like 5 hours supporting PyTorch. So it's actually pretty flexible. So we have no plan yet to support MXNet or some other stuff. But if you are a fanboy for those frameworks, just feel free to raise an issue or talk to us. We can make your dream come true. That's one thing. And the other thing is the TonY history server. So as you know, like for example, if you're running like Spark job, right, there'll be like a very nice Spark history server. And also if you're running MapReduce, there'll be a MapReduce history server. But however, it's nothing for like TensorFlow job. So this is something we plan to build as well, and it's already in progress. And maybe if we got a chance to talk about this again later, we can have a demo for TonY history server as well. So this will give you like the overview of how your job is going, and also give you all the information needed. For example, how many GPUs are used in your machine, in your job, or like how many GPUs are used in your job to help you tune your job. And this will, have you ever heard like of the elephant? No? Okay, so Power Elephant is like a tool to help you tune your job, right? So for example, especially at big organizations, right? For example, if you are starting a job, you don't know like how much memory it's gonna use. So normally you just like ask for as much as possible. For example, if your job only needs like 1 GB memory, you will still ask for like 10 GB, which is a huge waste of resources. So if you stop Elephant, it will help you tune your job. So you can like, for example, if you understand it only takes like 1 GB in the next job, you might only want to specify 1.5 GB. So we also have integration between TonY history server with the Docker Elephant to help you tune your job. And next thing is Docker support.
So this is something also like in our top list, because right now you don't have to use that Docker. You can just upload the Python stuff into like the command line or go to the ASCII it will work. It does not require Docker. And also we don't actually even support Docker, but it's also in our top list. We plan to support Docker very soon and make it work. And also our maybe near-term plans to make TonY not only like TensorFlow yarn, we'll make this like more like a machine learning like toolkit on top of Hadoop. So basically, we're gonna support different deep learning frameworks. We're also gonna support different like communication channels between the nodes. For example, even like the guy, like the professor mentioned in his talk. For example, we can support different like communication strategies, different stuff between the nodes talking to each other. Yeah. And yeah, that's it. So and as I mentioned before, it's already open source. So if you give us a star, you can get a sticker. So